genai@sif. Today we are going to learn about transfer learning. Let us begin the happy learning path. What is exactly transfer learning? Transfer learning basically, for example, GPT-3 or GPT-4 are trained on a massive amount of data, correct? That's are in billions, and then it can be fine-tuned on a particular task with a smaller data set to get the desired result. Suppose there's a left hand side knowledge learned by the pre-trained model is getting fine-tuned by training additional layer on top of the pre-trained model, keeping the pre-trained weight fixed. This is the main important, that is the pre-trained models weight are still fixed, just a small amount of data is used to additional layer for on the pre-training models. So what exactly it is fine tuning? It means again training the pre-trained model. This is what. And second is on a specific domain or task. And how? By using small data sets, few hundred or thousand examples. What actually it does? It updates the model parameters with the work specific data, but it do not change the weights. It preserves the knowledge of pre-trained model because the weight is not changed. The success factors are how similar is the pre-trained data and the task specific data. Suppose there is a data which is already used for classification purpose, but it need to be retrained on a domain specific classification. Then it will be very helpful. Hyperparameter and the architecture of the model are the success factors and amount of training data that is available. So what are the advantages and disadvantages? The first advantage is generalization. As LLM are trained on variety of tasks, it can be general. It has a general sense which can be used on the other NLP problems. Because it already know how to tokenize, how to create the vectors. So they have these concepts. Reducing the training time because it's already been trained, again no need to retrain on a billion of data, as well as it knows the syntax and the semantics of the NLP process. Improve performance, good for cases where learning data is very much limited. At the same time, where there are advantages, there are disadvantages. So limited flexibility, as trained on huge amount of data, so less flexible towards the new domain. Second is previous model biases and inaccuracy is also getting transferred. Third is the privacy concerns as the ethical concern of pre-trained models. That is also a concern. So this is now what it is. And now in the next part I am going to show you how actually this particular fine tuning done programmatically. So here is one of my code sample which I have run on the Google Colab by using the Hugging Face example. Thanks to Hugging Face. So here first of all I install the transformer dataset evaluate. Okay, then I log into the notebook of the Hugging Face hub. Then here you can see I have loaded the IMDb database. From the dataset, load the dataset IMDb. Okay, so there are two fields in the dataset: text, the movie review text, and the label a value that is either 0 for a negative review or 1 for a positive review. I have done IMDb test 0. Then here you can see how the data is. The text is here, label is here. The main is then there is a pre-process. The next step is to load the DistillBERT tokenizer to pre-process the text field. So I have used the DistillBERT tokenizer. From transformer import auto tokenizer from pre-trained model DistillBERT base uncased. So this is my tokenizer. Then I have create a pre-processing function to tokenize the text and truncate the sequence to be no longer than the DistillBERT's maximum input length. So what is predefined, it should not be more than that. For that there is a function, okay, example text okay, truncate is true. To apply the pre-processing function over the entire data set, so dataset map function is used, and you can speed up map by setting batch is equal to true. Okay, when you do this, then multiple elements on process multiple elements of dataset at once. So here you can see I have used the imdb.map pre-process function. I have done this batch true, and this tokenized IMDb dataset is not available. So I have used PyTorch to train my data, create a batch. Okay, for example, now create a batch of example using data collateral with padding. It is more efficient to dynamic pad, okay, the sequence is the sentences to the longest length, so it helps in the padding to create the length of the maximum length of the this particular sentences in a batch during collation. So instead of padding the whole data set to the maximum length, we need whenever where is needed, it will do it dynamically. I use PyTorch. Here you can see I have used data collateral with padding. Data collateral with padding tokenizer has been given, and here is at my data collateral. Now we have evaluate, including a metric during a training is often helpful because it evaluates the performance of the model. Quickly load the evaluation method with the Hugging Face evaluated library. For this task, load the accuracy metrics. Okay, if you want to more, you can go to Hugging Face tool and you can see how it is. So I have just imported evaluate load accuracy, then my accuracy is saved here. Then create a function that passes your prediction and label to compute and calculate the accuracy. So here you can see I have written a function that compute accuracy, and here prediction and label is there. Prediction np argument axis is 1. Then it returns with the accuracy dot compute function, where I'm just have to give my reference labels and the predictions. So it will help me to compute the matrices. So train before you start training your model. Create a map of the expected IDs to their label with ID to label and ID to label to ID. So we have to create a map of the expected IDs. So see here I have the ID to label and label to ID. So here negative is 0, positive is 1, then label to ID is negative is 0 and positive is 1. So I have just reversed both the conditions. So I have already started training my model. So load BERT with the auto model for sequence classification. Okay, because this is the auto model for sequence classification along with the number of expected labels and the label mapping. So here I am using importing auto model for sequence classifications and training argument and trainer of the transformers. And here my how I have to do it, like auto model dot for sequence classification dot pre-trained method, where I have to pass my model BERT base uncased, number of labels, ID to label and label to ID, so that in any scenario it should not fail. Okay, so at this point only 3 steps now remain. Defining the training hyperparameter in the training arguments. We have to define our hyperparameter in the training argument. The only required parameter is the output directory where I want to save the data. Specify where to save your data, and if I want to push my model to the Hugging Face, then I have to set this push to hub1. Then rest things, I think it's easy now. We can go ahead. So training argument I have created. Training argument I have defined its output directory, the learning rate, per device train batch size, per device evaluation batch size, they both are same. Number of training epochs which I want, I'm just running 2. The weight of the decay is 0.01. Evaluate strategy is epoch. The save strategy is also epoch. Load best model at the end, which one is the best one, it will load that one true, and push to hub is true. Now I have called my trainer. I have to give my model details, the argument details, the train data set which I have earlier, the evaluation data sets, the tokenizer, the data collateral for the padding concept, and the compute metrics. So I have already given all these things, and now my train will start training my model. So I have used by default GPU. So you can see here the response. The loss is 0.211490 in the epoch 1, and then accuracy is 0.91. Okay, so this is fine. The final, you can see here that epoch, training loss, validation loss, accuracy, this all are the evaluation matrices which I have used. It's giving me my model output. Now this is fantastic, great. Now I have fine-tuned my model so I can use it for inferences. For example, I have used a text. This was a masterpiece, no complete faithful to books, but enthralling from the beginning to end, might be my favorite of the 3. So this is what text I want to analyze it. So here I have created a pipeline which is very much easy for testing your model. So I have just instantiated a pipeline for the sentiment analysis process with my model, and I will see it. See the transformer.import pipeline, classifier pipeline, sentiment analysis. I have given the name model, my awesome model is, and this classifier.text. So it's doing all those concept, and I'm able to get my label is 1, that is uh, my true, it is positive, and score is 0.999. So that's why I have shown you here how we can fine tune my previous data by using the Hugging Face libraries, transformers, and other part. Thank you and happy learning. Do let me know if something is missing out. I will try to deliver best. Thank you. Please like and subscribe.